So let's look at the approximation of this model using the Skogetad's half rule. Now again in the step 1, we have to express in the gain time constant form. So we have this already expressed here for this model, negative s plus 1, s plus 0.1. We get 10s plus 1 simply by multiplying it by 10. So you have to multiply the numerator by 10 as well. And you have to do the same for the other terms. Now in this method, we have to identify the first two dominant time constant. So you see that the first dominant time constant is 10. All the time constant, if you look at all the time constants, 10, 5, and 2. So the first dominant time constant is 10. The second dominant time constant is 5. So tau 1 equals 10 and tau 2 equals 5. Okay. So in step 2, we have to approximate all the terms except the two dominant time constants. So in step 2, what to do? We have the original transfer function there, 100 negative s plus 1, 10s plus 1, 5s plus 1, 2s plus 1. We leave these two terms, and then if we approximate this term, we get e to the power 2s, and this one e to the power negative s. So we end up getting what is called this beta g the s. Okay. We'll have 100 e to the power negative s, 10s plus 1, 5s plus 1, e to the power 2s. So this gives us 100 to the power negative 3s, 10s plus 1, 5s plus 1. Okay. So now if I express this to be theta tilde, this is 3, and I have tau 1 equals 10, tau 2 equals 5. Now to get theta approximated, we add with this theta tilde tau 2 plus 2. Okay, so we have tau 2 to be 5, so theta tilde will be 3 plus 5 over 2, which is 5.5. Okay. So that's the half rule. So this is in step 3. We have to get the approximate value of the time delay. We have to add with this theta tilde, which we got in step 2, half of the second dominant time constant. Okay, and to get this tau approximate value, we'll have to add tau 2 over 2 with tau 1. So we'll have this 10 plus 5 over 2, which is 12.5. So finally we get the approximated transfer function equals, the k remains there. Do remember that there is no change in the gain. So 100, and we had this, and then adding half of this, we get e to the power negative 5.5 s, and this becomes 12.5 s plus 1. So if we use the Skogetad's half rule, we end up getting the first order transfer function something like this one. Do remember that if we will use the Taylor series approximation, we would end up getting 100 e to the power negative 8s over 10s plus 1. So that's using only the Taylor series, and this is using the Skogetad's half rule. So you see that we get the two different formulation where nothing is if we use only the Taylor series, the dominant time constant remains the same. In this Skogetad's half rule, the dominant time constant also changes by adding half of the second dominant time constant to the dominant time constant term and the half of the second dominant time constant to the time delay term. So that's the name is Skogetad's half rule. So we saw these two different approximation method for higher order models to get lower order models from higher order models.